They call everything evidence, so that's the same thing as open image. We are going to open an actual image file. Because I made an image file. So I made an image, I saved it on the local hard drive. The image is just a DD image. It's just a raw DD image. Everybody know what DD is at this point, right? Do we have anybody who does not know what DD is? Yes, we're okay? Good? DD, do you know what DD is? In Linux, there is a tool called DD, disk dump. When you copy a drive, the first sector to the last sector would just get copied out and dropped to a file. That's all it is. So from the beginning of the file to the end of the file, it will look just like the hard drive. It is exactly the same thing. It's very simple, very straightforward, just drops every sector into a file. Good? Yes? Okay. We are going to open the image file. So click Next. The path we are going to is going to be, we're going to this file right here. Go to C, Data Recovery Images, NTFS, NTFS Quick Scan. That is the folder we are going to. Coincidentally, all of this is typed in the book in various places, but we will. Can everybody see that? NTFS Quick Scan. NTFS Quick Scan. Good? All right. So in that folder, you will see several files. The DD image is the actual one that we're looking for. The DD, the one that says NTFS Quick Scan, is the copy of a whole hard drive. It's exactly the same as it would be if I clone a hard drive and stuck it on my computer. And there's no difference, except that it's in a file. Okay? And then the others are MD5s, which are hash. We'll talk about hashes, and CSVs. So we're going to open DD. Right? Click on that one and say Open. Then say Finish. All right. What's that look like?
That's a graphics file, right? 3A?
Nope. You've seen it like 20 times this week, but it's not a graphics file. It's the beginning of the hard drive, right? So in the beginning of the hard drive, what's the first sector? Yep. It was MBR. See, 55AA. And that's the beginning of the boot record. So that's the beginning of the first sector. And what is this right here? What's that content?
Oh yeah, that's the what it's formatted as, the file system.
Yes, this is the partition in the file system. What kind of file system is it?
NTFS.
Yep. See, set right there. 07 is Windows. So this is what we've been looking at all week, right, on hard drives. So we're looking at it actually here, physically. Now here's the thing. This drive is corrupt. Now if you notice, it does know it's got a partition, right? How does it know the partition? How does it know what it is? How does it know that there's a 40 gig partition?
07.
Well, yeah, it's right there where that 07 is. Exactly. It's right there in that MBR and that partition. We looked at it, and this content in here tells you how big it is. That's where that comes from. That's the first piece. Second piece, look at this. Unrecognized file system. Okay, now, at this point in time, how would it know it's NTFS? This,
The 07?
well, the 07 says Windows. It doesn't have to be NTFS, does it? Just means I have Windows. Now, sector 63, have a string in it. You'll see your NT loader and you get sector 63, blah, blah, blah. It'll have NTFS in it, so it's looked at sector 63. So it knows we're there. But you see, it's still unrecognized. There's corruption, and it cannot figure out how to deal with it. Most of the time, this is where forensics people stop. This is like, I don't know what to do. Data recovery people will go put it in a program, and they'll scan. They'll, you know, the difference is, forensics people put it in case in some expensive program that says scan, and we put it in a cheap program that costs $40 that says scan, or free, right? That's pretty much the way that happens. Otherwise, we're still scanning. But now, the scenario is, this is somebody's payroll, and I've got to have this quickly. I've got to have this tomorrow by noon. Or the other one that has actually happened is, there's an oil rig, and it's burning in the middle of the ocean. It's burning in the middle of the ocean. And there's a configuration file, and if I get it off the computer, I might be able to get the halo system to shut down and no fire will happen. But if I miss it and I can't get it fast enough, then the whole rig's going to burn to the ground and oil's going to run out into the middle of the Gulf. Right? So if I save this file, I'm in good shape.
That'll be $900.
Right. No, that's $1,200. I had to write a letter, and so all right. So that's the story. So I want this file as fast as possible. Scanning may take it a while. I may not even know what my result is or if it's even useful at the end of scanning. Right. So this will kind of slow me down. So I'm like, crap. Now I've got to do something else. Now, just so you know, before we move on, because this was just to show you. This is a tool that's supposed to be able to parse this stuff, but now it's corrupt and it can't make it any further. And this would have been where a lot of forensics people went. In hex right here, I can do a lot of the same stuff I was doing in X-Ways from a standpoint of searching for stuff, find stuff, cut and paste. I can even find a JPEG and cut and paste it. Because you can actually you can click in a box, you can hit Control F, you can search for a JPEG. And then you can sit here and you can go, hey, I'd like to highlight it, and I can save it. So you can actually do those things. It even has a semi-gallery view, which isn't very helpful, but it can do it. And that's about it. Otherwise, your files would show up in here. I'd actually have file names. And if I highlight stuff over here, there's something called an interpreter. Here's my hex values interpreter. I can actually look at this and say, what time did something happen? Of course, that's not time, by the way, that we're looking at. So those bytes don't equal time, so those are incorrect. But this is how you would interpret certain pieces of information. Okay? Everybody kind of understand where I'm going with this? So, are you okay?
So if you were back to your grandmother looking for her uncle's picture or something, you could actually search for an FFD8 and FFD9 and extract that, and you could see what it was.
Yes. As a matter of fact, that's exactly what the software is doing for you. It starts with this file, and it does exactly this. It goes Control F, but it's doing it, and it's just searching, but it's not going to do Control F. But I'm just saying, it's like, so FFD8. Now here's the thing. When it searches, now this, remember I told you if it was a real file and not embedded in another system, it would be the 512 byte boundary. So there's the 512 byte boundary. So is this really a JPEG? No. So this you can just keep on going until you find, and eventually it'll get to somewhere where there's a FFD8, and eventually a JPEG will show up. That's not one. I don't know how far I'll have to go in this. Usually if I do this demo, I do it like on a thumb drive where it's more obvious. But eventually we'll get to one because there's got to be a JPEG. Almost every system's got it.
If you find one at the beginning of the sector,
Yeah.
copy the hex out of it,
Yes.
and that will be the entirety of the file.
Well, so you would have to search for FFD9.
Okay.
And then mark between FFD9. Now this is one thing that FTK Imager, as opposed to another tool, is not awesome at, which is marking something in between.
Right.
So you can find the header, and I could just cut and paste a big chunk and find out what it looks like. Unless I go find where FFD9 is and mark it and then cut it out, I would just get a segment of the picture instead of the whole picture.
Because you don't know if it's contiguous, do you?
Right, that's the other problem, is in this case it might not be contiguous. And so that's kind of the whole, you just keep going basically. Now, this is one of the things where like X-Ways forensics, like see, in this tool I cannot search for boundaries. X-Ways forensics does. Like X-Ways forensics says search on 512 byte boundaries, ignore the rest. And so that's why I'm sitting here hitting F3 trying to find one. Like I could actually just, if I knew, I could go find one, and then eventually I would get to a picture, because there's got to be one on here. It's a 40 gig hard drive. There's stuff here somewhere. So, but this would be easier to do if I just actually set one up to show you what we're actually looking for, so that we don't do this all day. But eventually I'd get there. And that's what carving programs do. That's what any of the photo rec programs are going to do, is they're just going to search for FFD8, FFD9, cut it out. And that's why they look corrupt or something else will look funny. Right? Good? Pretty happy? And then you can usually even tell when you get to one that's actually a real JPEG, because it'll have EXIF information or something down here. You'll actually see the other stuff. So like this might be an embedded picture in something, if that makes sense. And then I just highlight, cut, and paste. And that was actually how I made those test files that were on the desktop. At some point in time, I did that as a demo. And so this will be, see this? This is the definition of the picture. And if you see at the top, what does that look like? It's the top of a picture. What is it probably? Can you tell just enough from the color? Trees. This is right. It's the top of the trees in the sky. And so if I kept going, it defined the space for the picture, but I only cut out a certain portion of it, so it just didn't display the rest. There's nothing else to display. And so that's all I did was do, and then let's see, here's another, there you go, trees. And so that was exactly what I did to make this picture, was I just did that, and I just highlighted, I right-clicked, and then you just say, save raw data, and spits it out. As a matter of fact, this is a DD image. If I highlighted the whole DD image, if I just did Control A and did this and highlighted the whole thing and right-click Save Raw Data, it'll be a copy of this. It'll be a copy of the whole DD image. It's the same thing. Everybody understand? So, all right, so at this point in time, I'm just trying to get you used to like seeing some of this stuff. The other thing is too, like, I mean, it'll show you pictures and files if there were files to be seen. It would show you stuff if there was stuff. Like this is unallocated space, this is all blank. You know, the other thing is too, you can kind of tell really quick, obviously there is data, because as I'm looking at the system, when I scroll through, there's actually data. So you can actually see physical data. So this is, you know, it's not encrypted, it looks okay, blah, blah, blah. Everybody understand? I can do this with rate arrays and things like that all day long. All right, so this tool isn't going to work for my purposes, so close it. One of the tools that does work for my purposes most of the time is that one I briefly showed earlier, which is called Disk Explorer for NTFS. Open up Disk Explorer for NTFS. Now do not go to the image file yet. I want to show you something. If I had a corrupt drive, and I open up this tool, this tool is very useful for me to touch specific things that I want. It doesn't touch everything. It only touches what I ask it to touch. And I can see things not only in hex, but also process the operating system. So X-Ways Forensics that we were using earlier is expensive. It's at least $800 to start. So for a forensics tool, it's not expensive. But for a data recovery tool, it's kind of expensive. This tool's $50. And this tool can be bought in a bundle. So this tool can do basically some of the same stuff as X-Ways Forensics that I was showing you earlier. So this is my poor man's version of X-Ways Forensics. Everybody okay? So what I would want to do is this sees the partition structure. Remember we got 4 partition entries? Well, it knows one of them is NTFS. This is our local C hard drive. I want to show you something about that. Double click on your NTFS entry. We're looking at the laptop. So this is now the valid boot sector. So I'm actually in the boot sector. But once I get into the boot sector, Disk Explorer parses data. And so look at the menu, Go To. On the menu Go To, I have all these choices, and one of the choices I would want to go to is Root Directory. So if you click on Root Directory, you will now see your tree of your data parsed from the MFT entries. This is the MFT entries themselves. Understand? Is everybody clear what I'm doing? If I wanted to go get a directory or something from the hard drive, see it right here, like let's say I wanted file disk. I can go over here and I can hit save. And I could export file disk. So I could just come over here and say, hey, I want this directory. I'm going to hover over it till I see file disk. And I would click it and I can save it and its subdirectories. And it will rebuild it by cluster. So it will actually touch only the LBA blocks associated with this file. It will not be thrashing. It will go specifically to the locations for this file only, or directory only. Does it make sense? So this doesn't touch. This is a lot like the Deep Star Disk Imager. It can actually touch the specific things we want, but parse the logical data, which I think that's pretty cool, right? And it generally gets through a lot of corruption. Like a lot of times I'll see corruption and I'll still be able to parse this really fast so I could get somebody's files in a minute. Like I took it off DeepStar, found it, whoop, there we go, done, spit it out. Happy? And that's how it works. This is how it should work most of the time. Let's open the image file. So hit cancel and if you got that. We're going to do open off the file menu. and say image. And open that same DD image that we opened earlier. You must have FTK closed if you're going to do that. If you had the other program, you have to close all the programs. So go to Drive, Images, NTFS, Quick Scan. You have to change the little drop-down box right here to say All Files, because DD is not one of the extensions it's looking for. So change that to All Files. And now, everybody here, at least at this spot? Yes? Anybody having a problem? I actually wrote all of these steps in the book. It's in the back of the book, in this section, which is all the labs, and every screenshot is in here for everything we're doing. So if you happen to want to follow along and happen to look at the folder, it's this one starts at page 564. This particular one that we're doing right now is 564. Okay, so did everybody open that image?
So this is the program where you would go to get payroll payment.
Yes, exactly. Because if I had, let's even say I had to work on an original hard drive, which I do not like doing. But if I had to work on an original hard drive, then this doesn't cause any of the other problems. Like I can't, if you mount that hard drive in Windows and you try to use it in Explorer, it's going to be like crawling all over the disk, making changes and doing all kinds of stuff. This program's going to specifically look at only the things I told it to look at. And so when I said, okay, I'm going to look at your hard drive at this place, I can find this file. And if there's damage in some other location and I never touch that damage, the drive will even operate fine. It'll only, when it hits that damage and I try to read that, is it going to abort or something happen. But this tool can also talk to the ATA command set. So it can do a retry, which most API tools cannot. So this tool can actually retry specific sectors. So, and it has some other things that I'm going to show you in a minute. But what I'm trying to point out is that on this image, what you will notice is this one is beyond what the normal ones are. You see the NTFS on this one? And everybody should see right here on the bottom. You should have an item that says /quick scan blah blah blah, and you have this content. If you open this, open NTFS, you will then see it says invalid boot sector. I cannot tell you how much work it is to make images that do not work. It's really hard. Like NTFS fixes stuff all the time, and I had to really struggle to make something that doesn't work so that we can use it in the lab. But this is a common thing I see every day. This is a real thing that actually happens. So it's invalid. Because what did I do in the other tool, or in this tool, when I went to the other drive? What happened? What did I look at?
Match file table.
Yeah, I went to the match file table by using the go-to menu. And where did I go?
So you
The root directory.
What does not happen now?
There's no root directory
Right.
because there's no master file table.
Well, it doesn't mean there isn't one. Something's corrupt, and for some reason we can't see it.
Right.
So for some reason, my go-to tool that I would always use to get to stuff very quickly is not working on this corruption. This is too badly corrupt. Now, and part of the problem is if the boot record's not there, it can't point to the right record, so it doesn't know where to go find the other record. And so there is a way. They have other tools that do go find those records, but they're used for different purposes. So believe it or not, I know the guys at Runtime. I talked to them. I called them and I asked them. I said, look, this is the kind of problem I'm having with your tool. I would like you to make a change to something because I know you have a tool that searches for this, but this one doesn't. So why don't we combine the tool? So here's what would happen. This would normally work, and I would normally be able to go to this, but I can't. But they have another tool that searches for MFT records. So I asked them to add a button that makes it quick so that we could just find the MFT entries and then pass it back to this tool. Okay? Close this. So if I had that problem and for some reason I couldn't get to it, they have another tool that's called Get Data Back for NTFS, which normally scans and goes through all this stuff. Anybody used it before? Yeah, it's a pretty good tool. It's actually very good at finding NTFS records and rebuilding them and stuff. But open this up. Now, now this tool was just meant to scan for trees, and like most tools, most of them don't do much if you don't just click go, 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 go. And then they build a whole tree and you wait 5 hours. What happens when you're scanning? What is one of the bad things that happens?
If you're scanning through the whole thing, you're
Yeah.
touching everything.
Touching every single sector, and you're not getting any results during that time. You wait till the end until it's done, right? So I asked them to do something. Now, in this, what we're going to do is we're going to click Next first. We're going to click Next. Now you'll see we're losing an image file. If this had been a real hard drive and we plugged it in, it would just show up. But I use image files from time to time too. This is actually very convenient when because I have an assistant who makes images, throws them up on the server, and then I can actually log in and then remotely put RAIDs back together and stuff like that. You use image files to do that. It's a lot easier. Unless they're really big drives, then you connect them to the system. So we're going to load an image file. So load this same file.
So you can be recovering data, I mean, doing work offline? I mean, not offline, but like off.
You mean like from right here, where I'm at? Yeah, I could do that in a minute. I can log straight into my PC, because my PC 3000 is online. I can log into that from here. I can log into my deep spars from here. I can log in remotely to my deep spars in my office and run them. And so, and then I log into my accounting machines and my main machine. Everything's remote for me.
You got a network KVM?
I don't need to use that to get to any of these tools. So remember, the deep spar, while it's a DOS tool, has a network module that talks to a Windows machine, and I log into the Windows machines and I manage them from there. So I don't need to do that from that standpoint. So I don't have any others that I need to. DOS would be the only time you need the network KVMs for that, but I don't need them for those machines.
What do you need to remote in the deep spar for?
Well, the current assistant that's working for me now has only worked for me for 3 months. The guy who worked for me before had been here for 3 years, so he usually knew what to do. The new guy, I have to show him what to do, and since I'm out of the office and travel a lot to teach, I log in remotely to fix things.
Just show them how to do it.
Yeah, or do it. One or the other, whichever way you want to look at it. So
Take your class.
he's seen this class like 6 times already. He's been through it, but you know, we're at a stage where some of the other stuff is more advanced.
6 times?
Yeah, I have like 800 copies of this. This is my 60th time teaching this class. And I videotaped at least 40 of them. So, yeah. Huh?
Poor guy.
Yeah, poor guy. I agree. He studies my books and my material and goes through it and the whole thing.
He likes you.
Most of the people who come to work for me know who I am before they come to work for me, so that's kind of unique too. So, huh? Yeah. So anyway, is everybody to this spot? You got NTFS quick scan? Yes? Everybody okay? All right, so we open this. Now, this button right here, options. Before we do anything else, let's click options. Now, I want you to think about this. It does not matter what tool we're in. Every tool has all kinds of functions to it that do specific things, and nobody thinks about them. They just click, 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 and they just spit stuff out. And that's all bullshit, right? You really need to think about what this does. Not only will you save time, it'll be far better, and especially if you have to run against the original hard drive. That would be horrible to actually just click, 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 click. So I want you to think about this just from this one's point of view. All the others have something different. But they just name things different. It's all the same. Deleted file recovery. This category right here. Recover deleted files. What does this mean?
Go through it. Oh, that's
Going
funny.
through the whole trash. It's going through the whole thing.
Going through the whole thing what?
Will it look at analysis?
No, not really. And the reason I say that is
I just saw the raw file recovery.
Exactly.
The raw is the
yes.
unallocated.
So-
That's carving. The other one is from the recycle bin, right?
It's not the recycle bin,
Or
but
fat tables or
yeah, right. So as I said earlier, when you delete a file, like E5, that little symbol E5 that showed up, that would be I'm a deleted file. Well, in NTFS, there's going to be a flag that's going to say I am deleted. But it's still there. It's still actually in the system. and it hasn't let it go. So it's not unallocated yet. It is deleted. And it'll show you, like in most tools, it'll know that they're deleted, and you'll just see like a red X on it. And it'll say it's deleted, but it still exists. And so that one is the one that this would be looking for, is that in the MFT entries, because this is only for NTFS, on this one. The other tools would be for other reasons. So it knows in the MFT it exists, and it's deleted. But it's not carving. So this would be like instantaneous. This is going to be like, look at the file records, found deleted files. Duplicate file names. What would those be? Why would it have duplicate file names?
Version?
What?
Version?
Versions, kind of yes, but what makes versions? What's the one of the main programs? Huh? What's one of the main programs to make temps files all over your drives?
Anything, Microsoft Office.
Office, right? Well, Office is like one of the main ones that makes temp files. Now let me tell you a little something about Office that I guess maybe many people know. Microsoft makes Office. Microsoft makes Windows. Microsoft can make modifications to Windows to compensate for things that happened in Office, which no one else can do, right? Remember the MFT entries, increment and decrement a counter when you make a change to a file or you delete a file? Well, Microsoft did not want every time that you opened the file and you made a temp file, it to actually have to go through the process of creating permanent MFT entries back into the system. So what they decided to do was put a delay parameter in Microsoft Windows. In Windows, if you are in Explorer or using the API, and you delete a file and you replace a file with the same name, within 20 seconds, it will steal the MFT record from the original entry. Try it. You'll see. You can do it. Not from DOS. Don't use the copy command. You have to do it through the API, which is what Office is doing. You can drag and drop a file into it. And if you delete a file and you replace it with the same file name, within 20 seconds, it will keep the original MFT entry and replace it. They did this for Office because when Word makes a file, it creates a new copy, a temp file. When you're working, it makes that file work. Then when you're done and closes it, it actually kills the original, replaces it with this temp, and recreates a new version. Takes the same MFT entry. It does not delete the original MFT entry. So it's making modifications at the same time. So there may be temp files that exist, things that are already deleted, things that exist that are the good version and not the bad one. So you may have things that have duplicate file names. In DOS or in the directory structure, you cannot have two files with the same name in the same folder. That doesn't work. But you can in the system. And so basically this is just building a virtual version and laying those out. But when you export those, you're going to have to tell them to rename because your current file system is not going to compensate for that. So you end up with files that have the same name that have good content in them that are duplicate. Okay? And they do exist still as part of the MFT entries as temp files. The temp file name exists. The other entry remained the same. It did not change the dates and times. That was the main thing that Microsoft was concerned about. If you changed the dates and times, then your Word document's dates and times would change. And so your creation date and your times would change. And you'll notice the creation date stays the same for Word documents as you're editing them. Right? That's from the file system. Okay, so this is all stuff having to do with MFT and deleted files. Right? The next box. File system identification. What does this mean? What is excessive search?
We're desperate. Is that by file header?
Not file header.
Extension?
Nope. What is file system identification? What category is that?
Is that like the JPEG?
Nope.
Oh, the
Partition type?
Partition types. Right. Okay. And what would excessive search do?
deleted or lost partitions.
Why would we do an excessive search? What would excessive search mean? As opposed to the other search.
Different versions of the MFT.
Nope.
The MBR is bad?
Nope. Under what conditions would we have an excessive search? What do you think an excessive search is? If I say I'm doing this excessively as opposed to just ordinarily.
It would look where the record is pointing, but it'll come back and search where the sector was bad.
Not in this case. We're getting a little bit off here. Okay.
Going to search the whole hard drive for an extended partition.
Searching the whole hard drive for partition. Why would I want to do it excessively or not excessively?
The hidden partition.
Not that.
Is it your overlap? No.
No. We're close. Come on.
Because the signature may be corrupt for the partition itself.
Under what conditions? What's the definition of partitions? We took for this morning when we were talking about partitions. Where do partitions have to be created? Not at the beginning of the header. Partitions are at the beginning. Cylinder boundaries, right? When did we stop using ordinary cylinder boundaries? Not at LBA. That was actual when we were laying it out in CHS. But on our operating system, in our file systems, when did we stop using cylinder boundaries?
GPT.
Not GPT. Nope. Okay. Before Vista, partitions were always created on cylinder boundaries. So there was always a calculation. It was built into FDIS. There's a piece of code that says your cylinder for your partition must always begin here. But after Vista existed, you can create a partition anywhere. So now you don't have a boundary to look at. So there's no mathematical calculation. So if you do not check this, it will ordinarily look at all the cylinder boundaries, which takes like 10 seconds. If it does not, if you check this box, it searches every single sector for a partition. Well, that is it, right? Excessive search for a file system. They just didn't say partition. Some tools say some don't. Like in test disk, it will say, it actually doesn't say partition at all. It'll just say, are you using this from Vista or Windows 7 or not? And it'll say yes or no. And if you just say yes or no, it's making a change for how it looks for sectors. It'll count every sector and look at every single sector. If this is a 2 terabyte hard drive, wow, it's going to look at every sector for a partition. And in this case, I maybe already knew where my partition was. We know we have partition. We know we only have one. It told us already. We saw it in the partition table. You can go in and look at it in hex. If you think you lost one, then it would not be in the partition table because the MBR would be overwritten because we already have a record of where it is. So everybody understand what I mean? So if we knew where it was, we wouldn't need to do that. If we don't know where it is, then we do need to search for it. I'm not concerned about that. So there's no reason for me to check that box because it will take more time. This will search the whole hard drive regardless of what I say for this one thing. This will cause me to look at every sector. Does that make sense? Everybody okay? And then raw file recovery. We just kind of discussed a minute ago. It searches for headers. There is a built-in table in this program that will say, am I looking for QuickBooks? Am I looking for MZs? Am I looking for JPEGs? Am I looking for? And it'll search every single file and carve them out. Right? So in this case right now, knowing what I know, do I want to check that box?
No, because you don't even know what's on there yet.
Right.
As far as the
Exactly.
So
I'm trying to do stuff fast. I don't want to do that. All I really want is MFT. All right, in here, what does use valid MFT only mean?
Current or?
Yes, that's correct. Current. The current MFT. If you formatted your hard drive, the file records that are in there are no longer current. They're still there, and they may actually have valid data in them, but they're no longer current. So this would be like, oh, I reformatted my hard drive, and oh my God, if I check that box, I will not get the ones that were there before. Right? So I would not check that box, probably almost ever, unless it was like, hey, I only want, never want to see the deleted stuff. Don't look for file records. And then this is the button I asked them to add. This button right here is called Quick Scan. And Quick Scan, what do you think Quick Scan does?
Goes to the first.
Goes to what?
Goes to the first MFT. The latest.
If you wanted to know what was on this hard drive and you know you only need the MFT, how would you search for those? Let's do it by hand. If you're doing it by hand, what would you do? What would you search for?
To the root.
$MFT, the file that.
Well, that doesn't exist as a real file, right? In the raw space. What does?
Oh, file.
File, right? You have to collect all the file headers. The file, F-I-L-E, collect them all, and then make one. And then it doesn't matter what is current or contiguous or whatever. I've got that record for all of them. And there's only going to be, it's a very small file. At best, it's going to be 300 megs. At worst, it's going to be, 28 megs or something. So it's not going to be humongous, and it's not going to be a lot of records. It's just going to go at the beginning of the first 512 bytes, search for file, until it finds them all. And it knows the vicinity of them, because if it can process anything else, there's a pointer to where the beginning of the first record is in the first 12.5%. Right? So it knows that. All right, so now don't do this. Just hold for a second, and just want you to watch me for 1 second and see what happens. I'm going to uncheck this box. And if I had unchecked this box, and real quick, this right here, bad sector strategy, it can talk to ATA command set. So it can pass commands to the ATA connector. So it can actually retry or skip, which most tools do not. You've probably not seen very many tools in Windows that can do this, right? Because they can't talk to the ATA command, they just talk to the API. And Windows times out at about how long per sector? How many milliseconds do you think? 600. At 600 milliseconds, it's too long for Windows to see it, so it aborts. So if it's longer than that, it'll abort. We've been reading sectors on some of these drives back here. It's been taking 1,000 milliseconds to read. Windows would have long aborted. It may be perfectly fine, but would have aborted. So you could retry, and it does at least continue on. All right, so nothing's checked. I'm not checking anything, and I just click OK. And watch what happens. What's it doing? Yeah, it's scanning. It's going to touch every single sector all the way across the drive. And you'll see sometimes, oh look, I'm identifying files. I've got MFT entries. Here's a Word document. There's an Excel document. There's a JPEG going by. There's some doc files. So again, even though it's a small drive, it's touching every single sector with just the normal defaults, right? So this is what I said. I basically said, look, I don't want to do that stuff. That's really bad. What I'd really like to do instead, and you can do this, is make sure that the box is checked for quick scan. Click OK. Then click Next. So you can go ahead and do that. Look how quick that happened. So now it found the MFT records. It knows content about it. It found MFT entries. It knows the file records. Now I'm going to try to tell you a few things about this page here. So this is the content that it found. It knows about this. It found one partition. It thinks it's this big. So it's got some partition information and some MFT entries. And it checked for MFT file starts. You see that? Now, this comparison right here for this MFT entry and the file starts right here, what would file starts have been? See how it's blank right now? And it's 0%. What are files? How do you know files on your hard drive? Headers, right? So that table it was scanning through for headers. If I let it go all the way through and it compared it, what it would do is it would take my MFT entries and it compared my MFT entries to my files, and it would see how similar they are. And then it would say, well, you got 60%. So that's a pretty good chance that it's a good recovery, because that's most likely going to be the real files and the real MFT entries. That's what that means. Now, I did not let it scan. So I just have MFT starts. I don't have anything to do with the file itself at this point because it didn't scan for it. But it found my MFT entries, and it knows my MFT now, right? Now watch this. They have a link to pass it back in memory to Explorer. If you click on the link, watch what happens. It went and it found the MFT entry. It took you in the other tool, the tool that failed before, that we could not find MFT entries. It took it and passed it to that tool. And now what's on the go-to menu?
Root directory.
Root directory. Isn't that awesome? Now immediately I can go to the root directory and start looking in hacks or do something. This is actually the drive that we were looking at, that we couldn't parse data on. It was too corrupt. FTK didn't make it through it. Incase might have barfed on it. All of our other tools might have barfed on it, right? We made it there. Now, aside from the fact it took me an hour to tell you about how to get here, if you had known to click those buttons, how long? 30 seconds? 40 seconds? Done? Now I'm in here? And that's the way that would have been. And we would have popped right into it. And in a minute or two, I could say, hey, look, I'm plundering through the system, and I can go and find whatever this was. I'm very happy they added that button based on my suggestion. But I'll show you. As an example, the guy that we did a recovery for is Mark Bessinger. And if you look in Documents and Settings, now you'll see two of them. See how you have Documents and Settings here and Document Setting here? This one's $1.20. This one, a X20 in hex. Starting to deal with bodies of. This one's a 20 and this one's an OF. This is a long file name. This is the short file name. They're the same. Look, they point to the same place. They're the same record. They point to the same directory. So if you click on the long file name, you'll see. You click in there, and now you'll see for everybody, you'll have a short file name and a long file name. So this is actually parsing that whole body of those records. And now you can see, I can see Mark Basinger. So here's Mark Basinger right here. So if I was going to go and save Mark Basinger now, I can actually go straight over. Now I wish they said it over here, but like you actually have to like highlight over something and wait till it says something so you can see where it is on the grid. But you can do, hey Mark, right here, Mark. I can't even see.
Down.
Down, 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 down. There's Mark. So you can hit save. Now, if I export this, you will notice it will rebuild it by cluster, which is also building it by LBA blocks. A cluster is a collection of LBAs. Remember we said earlier that there's a group of them that are together, and if I wrote like 1K, it's still going to take up 4K? Well, so we have a larger block of sectors that's bound together. So we'll have 8 sectors bound to one location, and it's going to be one cluster. And so the content that's there also includes what's called slack space, which is the previously deleted content that sits in that sector. And so if I did this and I said include subdirectories, and let's just say, now from a business perspective, let me tell you how I would do this, how I save content. All of my clients are sequential, so I have a number. So we'll be at 2046 or something like that. And at 2046 dash Mark Basinger. And so I'll have a file name that'll say that. But how long can our folders, our file names be? 256. So what if I'm recovering from a drive that has really long file names on it, and I use a big long file name? Now I've got an extension. Now there is a limit to how far deep they can go. So I think it's nested 8 or something like that. So 8 times 256 is as deep as it can go. If I'm recovering from a server or something like that, it might be really deep, which means it aborts when it can't write. It'll say, I can't write a folder name this long. Do you know what I mean? So I usually make a folder called RV, and I put everything in RV. And then I move it to wherever it needs to be afterwards if I can. So I might make one that's like this. I'll go to the root of the drive, always from the root. Don't put it in a subfolder because your file names are too long. So I'll make a folder, and I'll call it RV. I probably already have one. So I already have one. So I'll just call it this time just recovery, okay? So I would use just a short 2 characters or something to put it in. Then the only other thing I would do normally is, if I could, if they weren't too long, I might use his name. But more than likely, I'm only going to use the number, 1564 or whatever it is. We said 2046. 2046. So I know the customer number. And then I drop all of this in there. So I would do that, hit save, and OK. And now look, if you watch, it's doing them by clusters. So it's only touching specific spots. It is not doing what Windows does, where it just randomly goes over the whole drive. It's recovering specific clusters from that location. And it's not ruining the rest of my disk. And I got here really quickly to a corrupt section that came off of a deep spar. Does that make sense? So this is kind of what I do from that process, as I start thinking through all the things that I can do and how quickly I can do them. Now we have another problem. I export this data, and let's just say for some reason I needed to know all the dates and times. what's going to happen to the dates and times?
They're going to get changed.
They're going to get changed as I'm exporting this data. And so to forensics people,
You've got
This
this
is
match
bad.
file table. And
Correct.
The original.
yes. So here's what he just said, at least the problem is, there's no easy way. This tool doesn't print. They have actually told me they would make a print button if we would tell them what we want on it. I just haven't gotten around to it. It doesn't print the list right now. So when you're in here, the dates and times are the real dates and times. As we export them, the dates and times in the metadata is all changing, right? But remember the first day I showed you that the $MFT, you can save it? That's what I would do. I would save that file with these files. And then I would have a reference for what the dates and times were, because I can export that to a spreadsheet. Does everybody understand what I mean? So that would be the real content, and I would just save the $MFT, because this, at some point in time, this will just be done. This will be a click, but in the same thing, I can go back. This is actually the back buttons over here on the side, like Explorer would have. And remember right here, these are those files. Well, here's my MFT entries. These are all those collected together. So this one's actually kind of large, and then you just hit save, and I can actually save whatever the. I guess I should look at the screen when I do it at this point. So here it is right here, $MFT, and I could save that $MFT file. Bzoo. And so then I would actually be able to process that and have all my dates and times. And forensics people will need that. So does that make sense? Yep. And then the dollar. You'll notice here, remember that MFT mirror right there? 4K. It's only 4 records. And if you view it, you'll see it's just the file records for the 4 that go there. So it's just 4 records. And as you can see, I can do a lot of work in this cheap tool that can do these things. Now, there's one other thing I want to note, and I want to make sure. Now, this is not going to make a lot of sense. Maybe if you're doing data recovery and you're not going to do forensics. But let's just say, for an example, here's a file. Here's one right here. I clicked on this file. Remember that whole file MFT entry? Look at the content. You've seen it. I showed it earlier today, right? That's the raw data that is attached to this husky installer.log.txt. This is actually where the dates and times and the whole thing comes from. Well, forensics people are trained all the time to go and say, hey, this is this part of the body, and this is this part of the body, and this is part of the body. Well, that's what these things are here. You'll see these things that are the attributes. So on the MFT entries, they're called $10, $20, blah, 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 and they have names. These are the names: standard information attributes and file name lists. These are what they're called, and forensics people deal with these all the time. So people will talk about, what's the standard information say? Because I'm going to go look at that. And this is what Explorer shows you when you say the columns that have dates and times in them. So the data's in here. This is the data chunks in here. And these are already parsed inside this tool. And so when I go and look at them, I can see what they are. So let me give you an example. So the standard information and then these file names. I'm going to point something out, again, that most people do not know, and even FTK, you know, in a file name, there's a date and a time. Most people think that in what Explorer is showing you is the file name, date, and time. Well, what it's physically doing is you'll see your standard information, you'll see that, and you'll see your date and time. So this is the standard information, date, and time. This is what Explorer shows you. So everybody with me? These are the date and times. This is actually this part of hex out of that file record. That is what Explorer shows. These right here, these two are files. So when a file name changed, when you did something to the file name, it has its own date and time. The file name itself has its own date and time record. And so there's 2 of these. And so one of these is for DOS, the short file name. And one of these is for the long file name, Unicode file name, right? There's actually a 0, a 1, and a 2. So there's 3. So that's the dates and times for the long file name. When they don't match up, somebody messed with you. Somebody messed with dates and times or ran touch or played with them so that you wouldn't know that they were messing with you. Understand? Now, have you run FTK version 4, 3 or 4?
No, we just got 4.
Using for FTK 3 or 4? Did you notice that they added a new column for the file names, dates and times? There's a file name, date and time column. Because I know the developer and I told him about it and he went and added them. Because you can compare them to the original date and time, and since no one showed you this, this is not parsed by in-case or was parsed by FTK. So therefore, if the date and time somebody messed with them, you would only see standard information. They did not parse the other two, even though they're there. None of the forensics tools showed them to you. Does everybody get what I mean? There's other dates and times, and people mess with them. I mess with them all the time. I enjoy it. Here's the other thing. If you want to do testing, you want to do your own testing and see what the effect of making a change is. Like if I actually drop to a DOS prompt and I change something, I see what the dates and times do. The DOS prompt does something different than what Windows API does when you're doing it physically through Explorer. So tools will do something different than DOS will do. So if you want to see what really happens, do it in DOS. Do it in Windows and other things happen. Well, if you're trying to do your own testing, anybody tried to do it? You tried to use Xways to do your own testing? What happens when you make a change and you need to use Xways to review it? What do you have to do?
Refresh on the...
You got to do a new snapshot, right? And it takes a minute or two sometimes, right? So you'll make a change and you want to see what the change was, and you refresh and you take a new snapshot. It goes through and reads all the data again and displays it. This tool does it like that. So if I make a change, the only effect I have is so when I hit refresh right here, it will reread this location again right now. And the only effect is that it's going to move my cursor to the top of the entry. So when I do this, it reread the entire entry. So if I go mess with it, it's actually refreshing the entire MFT entry now. So I can use a hex tool, go edit something, or make a change, come back here, refresh, and see what happens. So if you want to play with your own stuff to see what happens to your stuff, I know it might be a little far for some of you. Forensics people will probably do it. But if you wanted to test, like make your own virus to eat files, well, that's what you do. You test it right here. So, and see what the effect is. So, but this is also another thing, at least another way to use this tool to parse other data, and it breaks the data down for you. That's kind of my summary of how I can kind of deal with stuff that's corrupt and damaged from that standpoint. There's a lot of tools you can run through. I mean, there is a side effect, like for instance, using that quick scan. Right now, if you hit next in the other tool, if you went back and used get data back, and you hit next, it's going to immediately just build a list of just the MFT entries. It won't do unallocated space or scan for headers or any of that other stuff, but immediately it will build me a tree that I can extract data from. I can't do all the stuff I can do in the other tool where I can go look at stuff in hex and make sure it's working and see what actually happened. And it doesn't, and it did not scan for deleted or unallocated space or anything else. But you guys get where I'm going with this? Without the quick scan button, there was no way to stop it from scanning. It would just do everything. And so I just wanted to get here fast. Our studios will. Our studios will just let you go straight to it. Our studios, you just right click and say open. Good? Happy? Yes? Great.
Quick question.
Yeah.
So you image a drive and it's got a virus on it.
Mm-hmm.
So now you have a virus in the other location.
You mean me personally, or you mean that I have...
The customer comes in, he's got a drive, his computer died, probably caused by the virus.
Mm-hmm.
You know, so now you image it, so now you have that virus in your system, right?
Well, you don't have it in your system.
Not executed.
Yes, you've got to execute it, right?
You have a file in your system.
Mm-hmm. You have a file on your system that has a virus on it. And so therefore, if you did go and try to run some of his programs, or you played with it in some way that caused something to execute, you could then reap a virus onto your system. But I don't go run their executables. I don't know about you, but I'm not running their executables. I'm getting their data. I usually then go and look and say, hey, how is the data look? Like now I extracted this data. Like Mark Basinger, I extracted his data. Then I would actually then physically be going, hey, now I'm going to go and see that I've extracted it. What did I get? So I'll go in here and I'll look and I'll say, you know, here's Mark's folder, and I'll go look at Mark's folder and see what it is that I have. Now, generally speaking, it's going to be like I might want, you know, I might want to go and look and say, what has he got in my documents? You know, what does this file look like? What kind of music does he have? What are his pictures? Things like this. So it is possible to get a virus through a picture in some cases, so you might want to be careful with that. But, I mean, I would go look at his stuff. Now, generally speaking, too, I would also do this. I'm popping into his pictures folder, and then I'm going to go and I'm going to change my view so that I'm actually looking at it so that it's a slideshow. And so in this tool, I can go and do this. And so I can physically just go look at all of his pictures and do something else. Now, this tool that I've replaced Explorer with is called Directory Opus. And sure, in Explorer, you can do gallery views. And this one can do gallery view too. But this one can also do some other stuff. Like I can change what the plugins are, and I can change what this content is, so I can actually look at things in hex. Or as I'm making my way through the system, you can do, I can drop to a DOS prompt in that folder. There's a ton of stuff I can do. One of the other things that's very, very useful is I can sync folders together. So let's say I have another hard drive, and Mark's got another folder, or what? So these two are not the same. I can actually then turn around and say Tools, Synchronize, and then I can say from RY to this folder, which is actually the opposite, right? I want the opposite. Huh?
I was just asking around if anybody knew of a good sync program.
Yeah, this will do, the best one is Beyond Compare, but this one is built into this tool, and it makes it so much easier for me to do things. Like I can actually go, I can say two-way, I can do a copy, I can do a byte comparison over here. I can say by byte comparisons if they're not the same. And then I can do both directions. I can say delete ones that don't exist in one, match them to the other source. And also if I'm copying from FAT32, the time is different. So when you say date and time, the time is off by 2 seconds in FAT32 versus NTFS. So when I do this, what will happen is I'll say compare. It'll run a comparison. It'll say, okay, I got 42 files here that are not in there. And it'll show me which direction they're going to go. And then when I say synchronize, it actually uses its own built-in copy routine. So it's not using Windows copy routine to make this happen. So it's much faster than it would be from the Windows copy routine. And it'll just copy those into that directory. So I can sync two directories together. Does that make sense? So this is one function that's built in. It also has a deduplication function. But one other thing that sometimes comes up. So let's say now I've created this directory. Now I have all these really nice things, and I would like a list, right? So here's one of the things that would happen. All of these files, if I wanted to see files all together, let's say, look, there might be pictures in this folder, and there might be pictures in this folder. But I don't want to spend all day looking through all these folders looking for pictures, right? So there is a method for me to produce. They changed their menu. It drives me crazy because I used it for forever with a different menu. I know it's here somewhere. Hang on a second. Great. Here it is. All right, so there's a bunch of content here physically that is all in subfolders. I can virtually display all of it together in one flat file, even duplicate file names or different pictures or whatever. So for instance, I just need to know really quick how many JPEGs I got or what's in there. I can go like this. I can flat file view mixed no folders. It will crawl through the entire system and make me one giant list that basically I can then sit here and go through. And so I could do this, then I could sort by types. I could say I want to see this, and then I can turn on in hex or some other thing, text, and I can start going through them. Which one's the right one? Understand? So that's pretty cool. It'll do things like PDFs and plugins. I can look at Word documents, link files, things like that. Make your own. I mean, there's nothing meaty in this folder. But